In today's lesson, we are going to see an introduction to the observer pattern. First of all, in case that you don't have the last lesson code, you can download it from here. So we are going to see an example of the observer pattern applied to the game development area that it will be called the area vision detection. As I was saying, we are going to do a new design pattern that will be the observer pattern. And we are going to see a use of this design pattern for reporting when an object has entered a field of view. Okay, what do I mean for a field of view? I mean this detection mechanism. As you can see, the enemies have a field of view. That means that they can look into a distance and into a range. Inside this area, the enemy can detect the player, and this is an example just for a 2D game. In the case of a 3D game, I have taken this example. Here you can see the field of view of the enemies. If the player gets inside this field of view and there is no obstacle in the middle, it will be detected. So that's the behavior we are going to implement right here. For this particular case, we are going to use an existing component called area vision detection that I am going to provide you. And the elements that you should only care would be these two public variable members. That will be detection distance, that it means the distance that this detection area is going to expand to, and detection angle, that it's the angle that creates this detection area. Okay, so you now need to download this Unity package into your project. So download it, go to Unity and import it. And both files will be created in the folder I. Okay, and these two files are plain from poly. It's a script that creates a polygon from some information points that will allow us to visualize the detection area. And the component that I have talked you about, area vision detection, that will provide you all the elements in order to be able to detect when the player has been detected by the enemy. So import them, and you should get both elements right here. So now that we have imported the scripts, first we are going to use it. The first thing that we are going to do, we are going back to the Unity editor. We are going to edit the level 0, and here we are going to select an enemy. In this case, we are going to select just, for example, this first enemy, and we are going to add the component area vision detection to it. Okay, so area vision detection, we are going to add it. And in the material property, we are going to use this material that it's just red material. And this is the material that it's going to be used in order to render the area that will be used as a detection area. Now we are going to do a small change in order to prevent the enemy to use its normal way to detect the player, that it was only about distance, because we are only interested just to know a little bit about the behavior of this area vision detection component. Okay, so what we are going to do is that we are going to set both distance detection and distance shooting to 0. That way, the behavior related to the detection of the player will be totally disabled. Okay, because right now we are only interested to know a little bit more about area vision detection. So now what you can do is just to play. And you should be able to see the field of view that is using the enemy in order to look for the player. Okay, if we clear the log messages and we enter inside its detection range, as you can see here, there is the message that is right now displaying this component, informing that the player has been detected. Okay, we are going to play a little bit around with this area vision detection, just modifying the properties in the inspector. For example, let's change it to a larger detection range. Instead of 8, let's put it, for example, 20, and the angle of detection, let's put it like 20. Okay, so if we play again, okay, as you can see, the area, the field of view has changed. Now he can detect to a larger distance, but the angle of detection is lower. Okay, back to the theory. The official definition of observer pattern is like this. The observer pattern is a software design pattern in which an object called the subject maintains a list of its dependents called observers and notifies them automatically of any state changes, usually by calling one of their methods. In words that we can all understand, an observer listens a subject for something to happen. We listen for events. Okay? In our particular case, for area vision detection, the observer is the enemy, the subject is area vision detection, and the event is going to be the detection of the player. Still in the theory part, these design patterns are used in the event-driven software. What is the event-driven software? A software that is designed just to process a stream of events. As a brief history of software and why this methodology has appeared is there. During the first decades of programming, the software was sequential. That means that you run a sequence of instructions one after the other. As the hardware improved and the software gained complexity, new ways of programming appeared. Now you need software that controls hundreds of thousands of concurrent processes at the same time. That's the reason why event-driven software and other methodologies have appeared. Back to our particular case, we are going to try to understand the whole observer design pattern just by analyzing this example. So back to the code. We are going to open the script area vision detection. So go to the code and open it. Okay. And find in the first lines of the script this particular line. Okay. This particular line, this is the event that the script enemy will listen. As we have said, the observer will be the enemy. The subject would be the script area vision detection. And the event that the enemy is going to listen from the area vision detection would be this one. This event will be triggered in the exact moment that area vision detection has detected that the player is inside the detection range. Then it will use this event to report to anyone who is listening that happens to be the enemy that the player has been detected. So what would happen in the code is that this method that you can see right here is the one that will be called by area vision detection in order to use this event. Okay, so let's check where it's being called, this method. Okay, so it's being called in 3 different places, but you don't have to care particularly about the 3 places. You only have to care that we are just checking some target, and in this first case it's going to always be the player. So what we are doing here is that we are checking if the player is inside the detection range, the field of view. If it's inside the field of view, then it will trigger the event that the enemy will listen. Okay, as you can see, here is the debug log message that was reported when we entered the enemy's field of view. Okay, and aside from getting this log, we are calling the method that I have told you about, and that this method will trigger the event that the enemy is going to listen. So let's prepare our code to start listening events. So on the script enemy, we are going to create a protected variable member that will make reference to the component area vision detection. Okay, so let's go to the code, and on the enemy script, we are going to add a protected member variable. Okay, and we are going to initialize it in the start method. Okay, so we are going to try to get the component in the start method. If the component is attached to the same object that the script enemy is attached to, we will retrieve that component. If it is not, we won't retrieve this component, and this would be null. Okay, so in order to listen for events, we are going to do it like this. Just copy paste this code and place it just after the code that we have done right here. And what we are doing right here is using a conditional just to check if we have the component. Okay, and if we do, what we are doing is that, okay, we have this event that is going to be triggered, is going to be called in the exact moment that area vision detection detects the player. Okay, so in order to listen, to process this event, we are doing it like this. Okay, by this way we are creating that this event is going to be processed by a method. In order to implement this method, you can do it like this: control dot, and it will appear the option to generate method. So choose this one, and just after the start method, it would have appeared the method that will be called when the detection event is dispatched. Okay, so the flow would be first of all, area vision detection would identify that the player is inside the field of view, and it will call the method to dispatch the event through the event system. Back in the enemy, the event will be retrieved by this method, and here we can process this event. Okay, so the moment that this method is called is because we have detected that detection event has been triggered. So let's summarize what we have so far. What we have so far is that the enemy, okay, is listening to this event from area vision detection. So the enemy is the observer, the area vision detection is the subject, and the event of player detection is this event. So we have all 3 parts in place, and we are processing this event in this method. Okay, so here will be the code related to process the detection of the player. So what we are going to do is just to display a debug log message in order to know that this method is being called when the detection event is being dispatched. So let's play something that you can easily identify. For example, enemy has listened from area vision detection that the player has entered the field of view. I think that this description is good enough to be able to differentiate it from the rest. So if we proceed right now to play it, okay, let's clear the previous log and let's go inside the field of view. Okay, so clear again the log. I think that we are on the path of this enemy, so in short he should be able to okay, so we have entered its field of view and we have got the message we were looking for. First of all, we get the message I told you about, that it was inside the area vision detection, but after that we are getting the message that the enemy script has listened from area vision detection. Okay, so we are listening for that particular event and we are detecting it. Okay, good. So let's do another example. Back in the code, we are going to add this line of code in the start method, just inside the conditional where we check if the component is there or not. We are going to listen to another event. Okay, in this particular case, we are listening the moment that we are losing track of the player, the moment that the player goes away from the field of view. In that particular moment, the area vision detection is also dispatching another event, and we are going to listen also to that event. Okay, so what we have done here is, okay, I'm interested to listen this other event that happens when the enemy loses track of the player. So what we are going to do here is control dot and generate the method to detect when the player has been lost. Okay, and we are going to add another line of code and make it different enough in order to be able to differentiate between both. The enemy listened from area vision detection that the player has left the field of view. Okay, so right now we are listening the two events that area vision detection is offering to us. Okay, so area vision detection is offering this detection event and this lost event, and the enemy is listening to these two events and processing, just showing a message in this case for each one of the events. So go back to the Unity editor and press play, and let's go inside the detection range. Okay, good. So if you notice, we got first our the enemy has detected that the player has entered the field of view, but after that we got, after a few seconds, you can notice 29, and well, it has changed right now because we have been detected again, but the sequence of time, you can see that first it has been detected and then the enemy has lost a track of the player. Okay, we are good. So now that we are detecting when the player is entering the field of view, and also we are detecting when the player is exiting the field of view, think about how we could improve our artificial intelligence of the enemy script, considering that we have this information. Okay, so go ahead and do it. And the result should look similar to this. What we have done is to create first a private Boolean member that we have called detected player, that will keep the information about if we have detected the player, if the player has entered the field of view. Okay, if we detect the event that the player has entered the field of view, we set this member variable to true. When we lose the player from the field of view, then we set this variable to false. Now, in the methods we are using to transition from the states patrol and check to the states and go to player and shoot to player, in these methods is inside detection range and is inside shooting range. In these two methods, we are checking if we have the component area vision detection, we are going to return the value of the detected player. Both is inside, is in detection range and is in shooting range. Okay, so it will work for both for the enemies who has this component, and for the enemies who doesn't have this component, it will just return the default behavior. Okay, back to the Unity editor, we are going to edit the level, and for the enemy, we are going to make a little bit bigger the detection angle. We are going to set it, for example, to 60. Okay, now we are going to play it, and the behavior that we should get is really similar to the one that we were getting before, but this time only when the player has entered the field of view, the behavior will be triggered. Okay, so this behavior is not triggered when we go in the back of the enemy, but when the enemy is going to detect us. Okay, as you can see, the enemy is now shooting at us, because right now the transition, it goes directly from walk, from check and patrol to shoot. Okay, so the next thing that you need to do is to consider that, well, in the case if it's in shooting range, just check also the shooting distance alongside this value. So go ahead and do it. And the result should look similar to this. Okay, we are checking this condition is in shooting range, and we are checking if we have the component area vision detection. Okay, we have it. Okay, the boolean that informs us that the player has been detected is true. Now we need to check if the position of the player against the position of the enemy is below shooting distance. This will return true or false depending if the distance is below shooting distance. If it's not, it has not been detected by area vision detection, we will return false. So back to the Unity editor, we should remember to restore the distance both for detection and shooting in the section of the enemy script. Okay, because right now at least we are going to use the distance shooting. So we are going to restore it to the previous value that it was 5, and we can also restore this value because this behavior is going to still work for the enemies who doesn't have the component area vision detection. Okay, so restore both values, and now yes, you can play, and we should get the same behavior, but now working with the field of view. Okay, so we are detected, it's getting closer, and okay, he is in shooting range, shooting distance, and start shooting. Okay, we are good. Let's repeat it again. Let's go into the path of the enemy and wait for it. And again. Okay. Okay, so the next thing that you are going to do is that the same way that we have done with the enemy, you are going to do it for the NPC. So use the component area vision detection in order for the NPC to detect when the player is inside its field of view. Okay, just follow the same steps that you have already done with the enemy, but for the case of the NPC. Try to use green material instead of red material for the field of view to better differentiate between them. Try to customize at least two NPCs using the area vision detection and two enemies using the area vision detection. So go ahead and do it. So what we have done here has been, well, since the NPC is also inheriting from avatar, and I have moved all the logic of the area vision detection to avatar in order to also get the component at this level, okay? And the only thing that I needed to do is to create two virtual methods at this level in order for later on, both in the NPC and the enemy, just to extend them in order to use them for each case. Okay, so right now what we have here is that both enemy and NPC are inheriting from avatar the reference to this component, if in the case that it exists, and they are also extending the behavior of listening to that area vision detection component. After that, in the NPC, we have just completed the extension of the behavior with checking that in the case that we have the component area vision detection, we just return the boolean that is set in the detection events, and that was it. Okay. And in what we have done in the Unity editor is just to, in two of the NPCs, we are using the area vision detection, okay, in this one and also in this one, okay. And in two enemies, we are also using the area vision detection in the ones that also have the patrol waypoints component. Okay, after that we have played the scene, and we check that for both enemy and NPC the area vision detection was working as expected. We are going to keep exploring the observer patterns, and the next observer pattern that we are going to do will be called System Event Controller. This time we are going to create a middleware structure that will allow the communication between different parts of the system through listening and dispatching events without knowing the existence of the others. The idea behind a middleware is that it's a piece of software that it stands on the middle of everything, and each module doesn't know of the existence of the rest, because each different module is only communicating with the middleware. The way it works is thanks to the event system. So what will happen here is that each of these modules will send events to the middleware, and also these modules will be listening for events in order to process them. A middleware structure allows to create independent modules that can be easily replaceable. That allows that a team of programmers can work in their modules without breaking the work of the others. Okay, so the idea behind developing a middleware would be that each of these programmers doesn't need to know what it's doing the other, because they are only going to communicate through the middleware. They are going to send events through the middleware, and they are also going to listen events through the middleware. For this particular case, the examples that we are going to do will be the next. The enemy is going to dispatch an event to report his death. Okay, so we have here's the enemy. It will dispatch an event to report that he's dead, and for anyone who is listening will listen. Okay, I know now that the enemy is dead, so I proceed to perform an operation. And for the spikes, the same. I know that the enemy is dead. Okay, so another operation, and the same for the NPC. And the actions that we are going to perform when we listen the event, for the game controller, when we listen the event, we are going to increase a counter. For the NPC, when we will listen the event enemy dead, we will change the message that is going to display the NPC when it's close to the player. And for the spikes, when we listen the enemy dead event, we will grow the size of the spikes. So we are going back to the code. And what the first thing that we are going to do, we are going to create the script called System Event Controller in our folder Assets Game Scripts Controllers. And this is the script that will be our middleware, that all the parts of the system will communicate through it in order to dispatch and listen events and process them. The next thing that we are going to do, we are going to add the code, the accessor, in order to transform this script into a singleton. Okay, so get any of the accessors that you already have and replace the reference with the name of the system event controller. Okay, and now back to the Unity editor. In the scene, you are going to create an empty game object. You are going to call it system event controller, and you are going to add the component system event controller. And this way we have added our middleware into the project. The next thing that we are going to do, we are going to create the event code, the event logic for the observer pattern to work. Okay, so for now, just copy paste this code and I am going to explain it. Okay, you can remove also the start and update. Okay, and what we are doing here is, in order to use the event system like this, you have to first to create a delegate, and by this way you are just creating a kind of a type that you can use as if it was a kind of a variable, and you can use by this way our event system. In different languages, they will do it in a different way. With C# is done by this way. And in order to just to throw to dispatch events, we are going to do it like this. We have our method, and in our method we are going to send to have two parameters, but they are not exactly two. Okay, the first parameter would be just a string of the name of the event. Okay, this is straightforward. This is simple. But this other parameter means that you can have a flexible number of parameters, and the type of the parameters can be anything. This will allow us the best flexibility in order to dispatch any kind of information through the event system. Okay, you have to consider that this event system is meant to dispatch events not every frame. Okay, this is meant to be used just to dispatch certain events that are not too frequent, because if you have something that is being dispatched, is being called every single frame, then the event system doesn't work, because the event system is not meant to work like that. The event system is just to work with events that are not too frequent. Okay, when I mean that they are not too frequent, maybe I mean that they can be dispatched once every 2 seconds. That's quite okay for an event system to work, but you cannot have an event that is dispatched every single frame, every single cycle, because then the system would collapse. The real power of the event system is about flexibility. It's not about performance. So keep that in mind when you create your events. Okay? So with this method, we can just dispatch an event so anyone who is listening will receive it. And with these two parameters, with the name of the event plus a flexible number of parameters, we can send any information we want. Okay, and here in the body of the function, first we check that someone is listening, because if nobody is listening, we won't dispatch the event. But if someone is listening, we dispatch the event with the two parameters, and someone in the other side who is listening will process this information. So the next step that we are going to do now is that we are going to connect the scripts GameController, NPC, and spikes with the previous middleware to listen for events. Okay, let's start with the GameController. In order to listen, in the start method, we are going to add this line of code. Okay, so go to the codes. And in the GameController class, in the start method, we are going to add this line of code. Okay, what is happening here is that the event is where we will listen the dispatched events from this middleware. And the only thing that we need to do is to implement this function. Okay, so control dot to generate automatically the method. Okay, and one thing that it's really important to stress out is that every time you add a listener to listen events, you have to remember to destroy it. In this case, in the case of the game controller is destroyed when you destroy the game. Okay, so we are going to use the method that it's inherited from monoBehavior destroy that will be called every time that this game object who inherits from state machine, who inherits from behavior, this method will be called when this game object is fully destroyed. And when it's fully destroyed, we are interested to remove the connection with the event listener. It's important to stress out this because you need to prevent as many memory leaks as possible. Okay, and if you don't remember to remove after you have already used the event system, then this reference is still in memory, even though the game object attached to it can be destroyed, but inside the memory, inside the running game, it's still there consuming resources. So it's important every time you add a listener, you remove that listener when you are not going to need it anymore. Okay, so you are going to repeat this same action for both for the NPCs and the spikes. Okay, so go ahead and do it. Okay, so we have added the listeners also for the NPC. In the start method, we are adding the listener, removing the listener on destroy method, and we have done the same for the spikes. In the start method, we are listening, we are adding the listener for the events, removing it on destroy, and the method to process it still is not implemented. So now let's see how we dispatch the event. We are going to find in the script enemy where you should dispatch the event. So go to the code and in the script enemy, you are going to find out where you should dispatch the event that will report through the middleware to anyone who is listening that the enemy is dead. So search for it. Okay, and the solution is in the change state, in the exact moment that we are changing the state and we are changing to the state die. In this moment, we can report to the rest of the system that the enemy is dead. So now what we will do to dispatch the event, we are going to use our middleware to dispatch the event, and right now we are going to copy this line of code, and in the place that we have found that we have detected that in this particular moment we are detecting that the enemy is dead, in this moment we are calling our middleware using the method in order to dispatch the event to the rest of the system. And this method had two parameters. One parameter that it should be there, the name of the event, and optional parameters. For the moment, let's forget about the optional parameters. We will see examples in other lessons, but for the moment, just focus on just the parameter name event. Okay, and we are going to define a constant for that name event, and this constant is going to be declared in the system event controller. Okay, we are using this as a middleware, so we are going to define there the constant. Okay, so go to the system event controller, and in here we can have this section to define our names for our events. Okay, so anyone that is communicating through the system event controller will know about this event. Okay, we are using this as a middleware. Okay, so other parts of the system only need to know about this constant. So now that we are dispatching the event in the right place, we should implement what to do when we listen this event. So let's start with the script GameController and the method that is listening the events, process system event. Okay, as I said, this method will be called when it receives an event. Okay, so let's go to the code, let's go to the GameController, and let's go to the method that is being called when an event is triggered right here. Okay, so how we can detect that the event that we are receiving is exactly this one? Think about it and implement the solution. Okay, and the solution should look similar to this. What we are just doing is that we know that when the event is dispatched, it will send as a parameter the name of the event, and the name of the event is what we have just declared right here. Okay, the game controller has the connection with the middleware, and he knows what the middleware is offering. Okay, so he's able to check the constant. Okay, so if the event is triggered, what's the name of the event? And we can compare that information in order to know if this is the event that we are looking for. So what we are going to do, just for the moment, we are going to just display a log message. Okay, just to know that this event has been received correctly. Okay, we are going just to display a log message. We can add that color. For example, to add a color, we can do it like this. Let's put it to red. Okay, and we need to use the ending tag color, so this message will be colored in red. it will be easier to see in the console this log message. Okay, so what I ask you to do is just listen both for the NPC and for the spikes. Listen the enemy dead event and just display a log message. Okay, so do it. Okay, and the code should look similar to this. What we have just done is exactly the same that we have done for the game controller. We are just checking the parameter name even just to check if it's the name we are looking for both cases, for the NPC and for the spikes, and displaying a custom message in each case. Okay, so now we can proceed to run it, and when an enemy is dead, we should see several messages. As you have imagined, there are multiple NPCs and there are also multiple spikes. So we are going to see plenty of messages. Let's going to kill an enemy, for example, this one, and it's dead. Okay, let's check the log messages. As you can see, I have toggled on the collapse flag. So as you can see, the spikes message has been performed 9 times because we have plenty of spikes there. Okay, the NPC message has been performed 3 times because we still have 3 NPCs alive, and we just got one message for the game controller because the game controller is a singleton and we only have one instance of the game controller. Okay, so our system event controller is working fine. We are dispatching events, and the ones that are listening for that particular event are getting that event and they are processing it. So now that we have our event system ready and working, it's time that we implement what we want. Let's remember what we want, that is the game controller will listen for the event and will increase a counter. The NPCs will listen for the event, and depending how many enemies you have killed, they will change the message that they are going to say to you. And the spikes will also listen for that event and will grow in their size. Okay, so do it. And the solution should look similar to this. What we have done for the game controller, we just are increasing a counter that we have declared as a private member variable here, and we are just displaying in the console the total number of enemies that are dead. Okay, for the NPC, we also receive the event. Okay, we increase the number of enemies that are dead, and we use that variable in order to decide which message is going to display the NPC when he's going to talk with the player. Okay, if there are no enemies dead, it's the default message. But if he has killed one enemy, this message, two enemies, this other message, and more than two enemies, it will always display this other message. And finally, for the spikes, when we receive the enemy is dead, we just increase the local scale by just 1 unit. Okay, if we go to the Unity editor and press play, okay, let's clear the log. Okay, and let's kill at least one enemy just to get the message from the game controller. Okay. Okay, let's see what has happened. Okay, so what we have here is that the game controller has received the event and he has increased the counter. The spikes also has received the event, and now we are going to check if they have grown. As you can see, they are bigger now. Okay. And finally, the NPCs also have received the event, and if we manage to go to visit one of them, we should get the message, the new message. Okay, so let's see. Okay, let's clear the log. As you can see, the message is the one that we have implemented. Okay, so let's go for another enemy. Okay, let's see. This is an NPC, this is an enemy. Okay, so let's kill this other enemy. Okay, all the enemies were dead because one of the enemies was colliding with the spikes, but the spikes are now bigger because this enemy has died, so he has triggered the whole system. If we check the messages, what we get is 3 enemies dead. The spikes have also received the dead event message, and the NPCs are also getting the event. To conclude the lesson of observer patterns, the new example that we are going to do is that we are going to implement a new event that will be dispatched when the NPC is dead. Okay? And the elements that will listen this event will, in the case of the game controller, when it receives the event, the NPC is dead, will increase another counter to count for the dead NPCs. The enemy will listen also for that event, and it will increase its detection range. Okay, both if you are using the area vision detection and if you don't have that component. And the spikes will listen also for that event, and they will reduce, they will scale down their size. Okay, so do it. And the solution should look similar to this. First of all, we have implemented the new name for the event, declaring a new constant for the event NPC dead. Okay, and we have found the place where we have to dispatch this event. Okay, that it's when the enemy changes its state to the state die. Okay, in that exact moment, you are going to report the event to the rest of the system, to anyone who is listening. And who is listening? Well, is listening the game controller, and we detect that the name of the event is the one, and we increase a new counter. Okay, and we display the message with the information. The next thing that we have done is, for the case of the spikes, we are also identifying the event, and we are scaling down the game object. Okay, just like this. Finally, for the enemy, it has been trickier to implement it, because we need to we need to increase both for the enemies who are not using the area vision detection and for the enemies that are using the area vision detection. For the enemies that are not using the area vision detection, okay, it was pretty straightforward, just to increase at 25% the current value. And for the enemies who has the area vision detection, we have created a public method, change distance area, where we change the distance area, and we need to create again the polygon that represents the area that the enemy can see. Okay, so now let's go to the code and let's test it. Okay, so we are going to kill one NPC, and let's see what happens with especially with the area vision detection of the enemies. Okay, so let's go for this one. Okay, don't go away, please. Okay. Okay. It has increased, but it's not really visible. Let's try with another enemy. Okay, okay, now it's more visible. Now it's more visible that the area of the enemies has increased. Okay, you can see that now the area is way larger. Okay. Okay. Next thing, we still have the event enemy dead. Okay, so if we kill the NPC, okay, the spikes seems similar to the original thing. That's because we reduce it so much that they seem to be. But if we kill that NPC, okay, let's kill it. Let's see what has happened with the spikes. As you can see, the spikes are smaller. Okay, let's kill also this enemy to grow the spikes, and the spikes are larger. Okay, our event system is working and ready for you to use it.